Hello, welcome to another video where we're looking at kind of dissecting the Spidey game. So we got this game that I was saying the just in the last episode that I could only play the 4-bit version, but I realized I actually had told well I knew something was different. I had a different version of the game, and there is a one with the 16-bit, and it's also got the like full intro screen there that you could see. Um, Gosh, you'll hear like the noise through my headphones. It's that loud. So, what I might potentially should mute that. I don't know. What I want to do is actually kind of look at this, and unfortunately, that's not what I can do. But if we look at this and we like here, I think um, the two binaries actually differ. So I thought I'd have a look in G Hydra. So this is kind of where the code starts. We've got entry. And can we get the size up? I wonder because the it's quite small. Um, I don't know how you would make the font bigger. Anyhow, um, this is actually a very different. Well, actually, no, I can't. This is a very different entry function. So it used to just go from there to this ret f, and I had actually, I kind of want to undo a couple. Well, there's a few things. This is kind of what it does. Interestingly, it uses ES before it's kind of initialized to anything, which is unusual, I think, but I'm also not sure because I haven't done much DOS development. But in essence, this is kind of this code is kind of copying all of the code. So from well, actually from all the way up here, 00, and it's copying all of this as well. So one of the things I did, so I can kind of step forward, is I pushed D when I was selected down here. We undo and gosh, use the keyboard a little. Um, so I actually came and pushed D, but I'll do a redo just because I have a comment that I wanted to keep. And that D kind of disassembles everything. So this is kind of where it jumps to, but in a different part of memory. But I thought I would actually kind of look through this in a debugger to see if this is actually kind of what I thought it was. Now, I couldn't actually get the. Uh, so, one thing I want is it the debugger to kind of pause when I start this, so I can see what the things are. But I actually found that uh, DOSBox X rolls with debug, the DOS debugger. Now, what is it? DOS debug. But so what we can do is go to debug and we can debug Spidey here. And one of the commands that you can do is T or trace, and they will say kind of what things are. So we can see ES is DF6, which was not actually what I thought it would be. I thought it might be code segment, which is the 19A6, but it's not. It's DF6, and it seems to be fairly consistent when I run it in debug. And what I'm wondering is I can kind of trace this through and see if kind of what I thought would happen. Um, Most importantly, all the way down to here, where it's doing the big move thing, which I've got lots of comments. And so here I might actually open up a new comment and kind of say in DOS debug ES equals 04980, and the other one we want is DS equals 0x17A AF. And I guess I might shove in CS here just to say that it is the same as DS. And that enter went through into DOSBox as well. It's kind of interesting. So this is not quite what I thought it would be, but given this, what we can do is we can do some tricks, I think. But in essence, it is still copying from 17AF. So that's like not where we're kind of defaulting to, but that is where we are kind of located. So I think that could be all right. But yeah, what I kind of want to do is we can go, where's my CX? I want this to go 1AE times, and it will just trace that many times, and you'll see it's gone from this repeats down to the mob. And what I might do is just make that over there so we can see kind of what is happening. So at this point here, it's not really too important, but I like seeing T just to see what's happening. So here we can see what it's wanting to push, and that's 4980, which is the same. So in DOS debug, AX is 0, 0x 4980, and the 38 will be the same. And we push that. And here we do ret f, which is return far, which I believe, go away, I believe will pop two things off the stack, the instruction pointer, then the IP. So the instruction pointer will be 38, and it's currently 37, so hopefully that will happen. And the CS will also get popped, so this will turn into whatever it was, 4980. So I hope that's what happened then. So 4980 and 38, that looks right, and we're down to this section here. So I wonder what else we can kind of, we can do a dump. So what I wonder I can do is whether I just dump this whole memory down there, or what I also wonder I should do is, because it kind of looks like this is a packed binary. And one reason I say that is because if we scroll down, we see that it's like right at the end, it's packed files corrupt, and I think that's used in some place. 116. Well, 117 is actually where the P starts, and that is there. And int 21 will be int 2140. Gosh, where am I going? Over here, int 2140 is write to file or device. So the BX we will probably need to know. And 2 will just be what, standard error. Cool. Yeah, so if it gets to this point, that's, I mean, I can start like kind of annotating this. There's not too much code, but I kind of want to see what happens at, like when we unpack everything, because like it's doing some like stars and mobs, um, which makes me wonder whether it is doing things. Yeah, and it's got to jump far. Or yeah, that's going to be the place that it jumps to, and that's going to be where the code lies. But it's after it does like a bunch of stuff. So what I wondered I could do is actually, instead of doing that, I can just run Spidey, and then run the DOSBox debugger, which goes here. And one of the commands I can do is help, and I can like dump some memory, I believe. Um, where did I see that before? I'll like dump memory. I thought I did see a place that I could just. Because what I want to do is kind of just save the memory, where after it's kind of got to this point, because at this point here I can do a bit more things. Um, right, memory, yeah, mem dump and mem dump bin, cool. So mem dump sig off and len. So I wonder if I could probably just write like all of that, like just from FOO. We can also like tab to see things. Are we in the right window? Um, maybe we need to get out of that. Yes. Because yeah, can we see what's happening? Um, I don't know. I don't know. Because one thing I can see in this, if we maybe make this go over here, and we just do that. Yeah. So there are a bunch of strings at the top of this file, and one of the strings in particular is rooms.simple. So, like, if you search for, say, this string here, there's only really one place that it is, and if you try and disassemble it, it's not really using that number as a string index or anything. So the other thing I thought of doing was, gosh, what I had just before, but if we look up what int is, it's meant to be CD. And we can see there are a bunch of CDs. In fact, there's even one that's decompiled as 21. This is the printing that is an error. So maybe we won't go for that one, but maybe like this, and we decompile it, and like that's 2D, and we don't really want 2D. Was there like an inch? There was an inch where it wasn't an intermediate, I thought. Um, into so it's just they're all the same. Um, so it does have to be an immediate value after it. So that's kind of annoying because say if I wanted to search for um, 21 3D, which was in the other one, that should look like a CD21. No, 21 CD, 21 CD, which does have a few. All right. That's something like that. The problem with disassembling stuff is you don't know really how far back you would want to do it. But going forward, you know where it is. But say, like, if I disassembled this, it might not be able to do it. And it's even given me an error. But I can do something there. So I can kind of go back and do things like that. But then, like, there's nothing here. So that's kind of interesting. But if I do that, that did a bunch. And yeah, all right. But anyway, what's this doing? It's doing 212C. So what is 212C doing? It's doing the get time. So we do know that the other one did have the get time. So what's this other one doing? That's 214C. I think I kind of want that to be there for this. 214C. Terminate process. All right, so this is like an exit, I guess. So AH will be that AL. Where did AL get set? Do we just have to assume, well, like AX gets set there, but that should imply AL is part of it. But this here is an exit, I guess. We label it, yeah. So might just label that just for thinking. Don't even know if it's a valid code area, but um, right. So 21.9 print string. All right. So it needs the what's a 10.2? Set cursor position. Set cursor position. I suppose I probably should do that. Print string. It's interesting, this print string. It's like everything up until the dollar, which I wonder how you print something with a dollar. I guess you just have to do a print char manually. Where was another one? Give me more things because I'm more interested in these 21s. So 21.9 is another print string. String. What does it print, I wonder? Right, so it does like a bit of a loop beforehand. Does it ever set dx? Uh, it also just returns straight after. Interesting. All right. What about another one? This one, 21.3D. We haven't actually. Where are my errors in this? 3D, did I say? And this is the one I want. Open file via hand. Um, it's like not in the best place. Open file. Uh, Using handle. So I guess we can probably say something like that. And so we have to know where our dx is and what it's set to. And this is a function. This is brilliant. So now we can actually just search for anything that tries to call this function. But I guess we can also see what this function does and like what does it do with the file handle after it gets it. For example, um, I forgot I was actually going to order lunch and my stomach just told me, so I might just are we allowed to do that? We're not. We are now. I might just do some off-screen, just picking a thing. Yeah, that was. Um, do. Gosh, I'm quite hungry now. Just looking at all the things. Oh no, not that. I don't. Right, cool. That puts a small time limit on things. Now that should be right. Cool. So what are we doing here? This is like reading a file. This is more like a file. We'll just call it open file there. What's this doing? It's like saving some stuff. Don't know what it's saving. I guess we could start taking notes, but I think I'll get rid of the C one as well. I found the gold. You open a file, you're going to do something with it. So what's this going to return? So on return, if the carry flag is not set, that is file has opened. So this jump is going to be file open success. File open success. And I guess this will probably print an error maybe. So what is something at there? We're moving to the data segment. All right. So the data segment, the maybe data seg is changing to 0xFB9. Cool. But like, I wonder if anything's actually there, because I need to remember that memory was kind of copied and we jumped to a different code segment. And I wonder if this was part of it. Who knows? Um, in fact, do I have my memory map? Not too sure. Right, so otherwise, this is still like an error has occurred. So we get some memory. What is this memory to start with? It's to be, and I think this section, like if we're in this section, this is like not the code segment I thought we would be in. It's interesting. I don't know. I'll go along and just try and work out what I can. We call a function here, and this is still in like the error case, because if the carry flag is not set, so jump not carry. I mean, I can confirm this with let's go back to here and jump carry. Jump CC. I've tried XX. So jump not carry. Jump short if not carry. So if the carry flag is 0. And carry flag not set. So I think that is legitimate. I kind of want to see what happens when we do open it rather than what happens if we error it out. It's kind of interesting. Right, so the first thing we do is we pop dx. What had we pushed? We pushed dx. So dx is just something that was passed to this. And then we move something to EX. That's just a memory location. We'll work out what it is another point. And we also put it to BX, and then we do was that clear 21 40 42. What do you do with this file? We're going to move it. Cool. So we're going to move it to somewhere. So AL is to end of file. So this is pretty similar code to the other binary, I gotta say. I would say that this is getting the file size really. So at this point here, we're getting that. Please no. And so we're clearing it to nothing. So we're just going to the end and offset by nothing, and that's that. And AX, BX is our handle. So this is file handle. Can we file handle maybe say what it is? No, can I not say what that is? Do that, yes. So you can't see that, but I also can't see that. I kind of want to say the address at whatever this is. Can I not like add a label for? No, I kind of want to add a label to the instruction. I can do a comment. Maybe I'll just do a comment then. So the comment can be is a file handle. And we can check that this was what it was. So open file AX was our file handle. Perfect. So here, if the carry is set, that means that there is an error. So if there is an error, we're jumping back up to the top. So they'll just get named when we name the function, but that's kind of an error case. We should probably. It's kind of interesting. It's already opened the file handle, but instead of like erroring out, which I think the last one did, I'm also wondering whether the last copy I had was just the freeware version back in the day, whereas now I found the version I was playing in my earlier videos, and it's probably not the freeware version. Or it could have some other things going on with it. I don't know. It's kind of an interesting area copyright wise, but we just won't talk about that. Maybe I will make some notes. So this one is here. I think I, yeah, already have some notes. No notes in it. Cool. So what do we have? Yeah. So it's kind of tricky. Unknown X. Unknown. Yes. Maybe I just want to say the full address. So maybe just question mark and this is going to be. Now I forget if this means. I I think this means that it's going to be the address at. But yeah, we shall see. 1D5B. This is a file. Um, it's used in a function. Use 5A41. We can just say that for now. And what does this one do? So this one there was an error. So this is we have succeeded. So uh, AX will be painter location. So that will just be the length of the file, I guess, in our case. I never actually said that this was in, just to say that. So this ES is most likely a file like buffer size, I would say. So maybe we could say something like this buffer size used at just a bit past it, just there. Maybe that's the notes I will take. And was that used earlier? No, not really. We do put DX to be there, so data equal 0x FB at 9. So we can say some of the addresses, none of these ones because they're all EX. And we haven't set EX here. So yeah, it really depends on what has called this, which we can find out. But I kind of want to see what it does with the file to work out that. So I think this is a compare against buffer size question mark because it does that, and this just goes to the same style of the function. So that will be if the size of the file is bigger than the buffer that we have given it, we should try again. Interestingly, does not close the file handle. It's just like, oh, an error, good, let's just try again. I don't know. Well, it makes for shorter code. Right, so this 1DF we had already said was buffer size, so that's set actual um, and so we clear these. We're doing an int. I could smell it. So we're doing a same seek, but now we're doing a seek set, and we're setting it to 0. So we can remind ourselves this is the file handle, and this is going to be seek start. Cool. Right, so the 1DF, that was the buffer size. Buffer size. Well, it's actually file size now. File size. And 5DD, we don't actually have that one yet, but we're going to be using it in a function. Yeah, about 21 3F. All right, we're going to read. So this is most likely going to be that window thing. So this is going to be our buffer pointer, and we can record that down in our little notebook. And we can say this is 5A72. We did that there. It's like in between there. File buffer. So this whole function is likely just reading a file. So we can say here read file. Easy. And then if not set, this will be the number of bytes. So if it is set, that will be an error, and that's just going back up to the same one. So I am quite happy to name the function read file. But I potentially want to say where it's reading file from. So when I see it in other places, I know kind of what's what. Um, well, what's this one? This we didn't actually look up. I don't think 21.9. Yes, I noticed 21.9 print string. Right, there was a print string. Print string. Um, so, yeah. And where's this going? Well, what's this string? We can probably find out what it is. It's probably in the same. Well, no, we've actually just set the data segment, so it's in FB B. Oh, FB9. Then 1D61. Hopefully a string there. And yep, that is just the title string. Cool. So this is um, string easy. So we do that, and then we do that, and this is just jumping to a random function. No, take me back to where I was. This isn't read file, I guess. If it's just gonna do a random jump to down here, that's got an exit. Cool. Where do you come from? You came from here. So this is the read file thing. And I guess I want to, yeah, maybe I want to go back here and gosh. Where did I come from? This is not there. It's like print title string. Print title string and jump. Because it just does a jump to this function and then wonder what this function does. I don't know. It's kind of funny. You get lost, but every little name you add in kind of makes it a little bit better. But yeah, so this I interesting. So if it ever errors, it just prints the title string and then jumps to this random function, which is probably going to do, yeah, was that? It doesn't really show me like which direction it is. 3558. Yeah, so it's like quite a ways up. Interesting. Um, what was the fail case on this failing? Um, so we set the data segment. So this will be whatever's at that. So we could probably have a look see at that. Does this no? Nah. So it's going to be that 929D, 929D. And what is there? There's a thing there. So I think it's jumped. Yeah, that's fine. It's currently got nothing, no bytes in 29. And we're just wanting one, currently nothing. Currently 0x. Currently, I thought so. It's really annoying. One, oh, that was a different one. Want that one. Um, and then you go to the start. Go to the start. I currently 0x 00. How to see Hugh fail at typing. Right. Cool. So that's that. Then we're pushing that. Then we're moving that same thing. We're setting it to 00. So maybe we should say something about that. So if D9, we know where it is, 929D. Oh yeah, it does know because it's seen that, but that hover over doesn't take you to the right place. Oh no, see it. Oh, it does take you to the right place. Yeah, that was where I was looking, but I got confused because it had the DAT 100. So set to 0 at start. initially, and then to 0xff at 59f7. Cool. Don't know what it does yet. Cool. And then we do bx, and then we're calling a function. So I want to know where the file stuff gets called from. This function. Let's have a look see at that so we can see references to this. There's a lot. All right. But yeah, I guess this is like copying file. Um, yeah, it's copying file, ignoring all those. It's copying from these things. So it does actually just take it from ES. Originally, and that comes from BX. Perfect. So this is going to, I want this to like maybe come down here. So this is going to be read file. Do we have like DX? Oh, don't let me scroll. So the file name, I don't know, is read file some to bx size, and dx will just be the file name skz. So it's dx there, and then this we can see what calls it, and like, is it interesting? What file names does it give? Oh, this is where I wanted to be. I also don't have too much longer. It's the start of working out how the room file is read. You need to work out where it gets read using the int calls. So now that we know things like this, it's colored that way, all right? So dx at 2 of this data segment, so data, I hate how this, I wish that it would, like if I grab it, so it's a big window there. I want it maybe that say that size, just like that, and I want it to just be in that location all the time. I don't know. You can't get the best from the SA. 1A6A. So if I don't know, just try and open that comment again, it's gone up slightly. And again, and again, and again, and again, and again, and again, and again. Like, why? Certain things are strange. So, what is this file at this? So, we can look at, gosh, 1A6A and two things. There's like nothing there. Now, there probably is something there, but I don't know what. Um, because where did it copy it to? Um, Gosh, where's my entry? Can we like just go back all the way to entry? Do you exist? No. Do I have to search for entry? Um, oh, how do I just find entry? You're like midway down. Um, just a bit up from here. Gosh, not quite a bit. Um, so this I already copied this stuff. Do I still have that? A debugger open. Because I wonder. Oh gosh, not much long. If we go debug as Spidey and maybe trace, so we start at 17AF and instruction is 14. 17AF. 17AF. 17AF and instruction is 14. We probably started there. 17AF means like this is kind of offset by um, a bit. But yeah, what am I thinking? Um, I don't know. I think I just need to kind of go through all of these and see if I can work out if there is anything there. Um, because what do I go to? 2D44 5E. Like yeah, there's just nothing there. So the question mark's like nothing loaded there, but something will get copied there. Um, but what I could do is look for the strings. Uh, like this is for 11.1e. See if that showed up. We weren't even where we were. I don't know. Well, I guess because it's opening a file, I can just work out um, where the largest file name is. Oh, and that's like the error string. It'll probably print that. Um, could even kind of take a note of it. Uh, File read error string. Um, and this one here is where rooms simple is. Rooms dot uh, and yeah, so when we do the file read error, that's probably what's happening. But yeah, I think for now I will leave it at that and see where I get up to. I might find some more stuff. I might hit my head against the ground. Who knows? It's kind of fun, but it's a little frustrating that the binary was packed. So I might look at unpacking it so then all the numbers kind of align up. So, for example, when I tried to go to that address, it would just know what is at that address. And I think one way of doing that is actually while debugging it, while it's running, just dump the code out, and then you can run that code because it's like unpacks and then reruns itself. But yeah, for now, thanks very much for watching, and I hope you enjoy your day. See ya.